Hi and welcome to this short clip going through a level question, this time on transition metals. So looking through it, it says the student has solutions A to E and the solutions are in no particular order, or the solution is contained in no particular order. Copper sulfate, chromium sulfate, iron sulfate, iron 3 sulfate and manganese sulfate. So with any level question, it's a good idea to plan out what you're going to do. First thing to do is identify the ions that will be present, the transition metal ions that will be present in each of those solutions. And what they ask you to do is describe a single chemical test that could be used to identify the 5 solutions, giving balanced equations and observations. So the chemical test would have to be the same reaction in each case, but give different visual results each time. So starting with the chemical test, you need to add sodium hydroxide and note the colour of any precipitate formed. So I've done the first thing, which is to say what you'd do. You'd add sodium hydroxide solution and note any precipitates formed and also the colours. So I've given you the colours of the first 3. I need to move the page up a little bit to make some room for the remainder of the answer. So just shift it up. Now we can put the remainder in. It's worth also pointing out that in the case of chromium 3 hydroxide, the grey-green precipitate will redissolve if you add more NaOH, and it will redissolve to create CrOH6 3-, which is a dark green solution. So again, we need to move the page down a little bit because we need to answer the second part, which is what happens when the student adds aqueous ammonia. So shifting it down once more. So this time it says the student added aqueous ammonia dropwise to each solution until no further change took place. Solution B formed a blue precipitate which then redissolved to form a dark blue solution, and solution E formed a grey-green precipitate which then redissolved to form a purple solution. So in our plan, what we've got to think about now is a bit of recall. So we want a blue precipitate and a dark blue solution. So if you structure your answer in that way by literally just writing down what they've told you, you can then think about what would cause those colour changes or precipitations just by adding ammonia. So remembering that ammonia in aqueous solution can actually also be considered as NH4OH, in other words ammonium hydroxide, so it's a source of hydroxide ions. This might help you think about it. So the blue precipitate is copper hydroxide, same as copper hydroxide that we looked at further up. And I'm writing it this time to show the water ligands and the 2 hydroxide ligands. So in the same vein, I'm showing the dark blue solution as copper with 4 ammonia ligands, which is the maximum amount of ligands a copper central metal ion can coordinate to. So just to mention the reason for that is because copper 2+ only coordinates 4 ammonia ligands, not 6 ammonia ligands like other transition metals. It's due to d orbital splitting patterns, crystal field theory it's called, that are unique to copper. Other transition metals also have d orbital splitting patterns, but the patterns defined with copper 2+ mean that it can only coordinate to 4 ammonia ligands. The bit you have to remember is that. You don't have to know about the details. Okay then. So solution B must be copper sulfate. Now let's do the same for solution E. So we've got the grey-green precipitate as chromium hydroxide, this time written as CrH2O3OH3, same as CrOH3 from a bit further up the page. And the purple solution this time is the fully 6 coordinated with ammonia chromium 3+, so CrNH3 3+ aqueous. Now I wanted the equations, so I need to put those in as well. Before we do that, let's identify solution E as chromium 3 sulfate aqueous. So if I can refer you to the precipitate formation equations above, further up the screen, for this formation of the blue precipitate in the case of copper and the grey-green precipitate in the case of chromium. However, what I haven't done is given the equations for the formation of the solutions. So in bold you now have the two equations for the formation of the solutions as opposed to the formation of the precipitates. So just to make it clear, I've highlighted them in the colours that they might appear. Okay, so that takes us to the end of this particular level question clip. This time it's not a particularly difficult one, but there's a bit of recall involved, so it's worth going away and practicing your recall if you found you were struggling in any aspect of this. But once you've got the recall of your transition metals, a question like this should be a gift. Okay, and for now, thanks for listening, and until next time, I'll see you soon.